Hi friends, this is PH 3501 lecture on solid state physics by Dr. M.R. Gadhvi. In this lecture, we will be highlighting the topic for calculation of the solid state physics, especially the atomic packing fraction and so on. Now, atomic packing fraction, that means the atoms within a unit cell is contributing how many percentage. As for example, the size of atom is very small and the size of unit cell is, let us say, large. Now, the occupancy of atoms within the unit cell is, let us say, how many percentage. That is what the mean of atomic packing fractions. As for example, in the simple cube, only 4 atoms are at the top corner plane and 4 atoms are at the bottom corner plane. Here there is a one big cube is given, but you just focus on a one of the corner of the cube, then top 4 atoms are on the top surface and at the bottom there are another 4 surface. That is what the mean of simple cube. Now, how shall I calculate the atomic packing fraction of it? So, in the syllabus we will be touching 4 varieties of it, especially the cubic set structures, where you will be calculating the atomic packing fraction. But as we are knowing and as we have seen in the past lectures, that in a cubic structure there is a Brevis lattice, then there is a 3 varieties of the cubic setup, and that is a simple cube, body centered cubic close pack and the face centered close pack. In addition to that, we will be also touching the hexagonal close pack. Okay. So, first of all, let us remind one more thing. The simple cube is a primitive unit cell because there is a in all only one lattice, because each corner of the cube having a one atom and each corner contributing 1/8 portion of it, and therefore the total available number of atoms per unit cell, that would be 1, because 1/8 into 8 corners, and contribution of each 8 corner is 1/8, and that is how the total contribution of the atom in the unit cell is 1. Okay. The coordination number. What is coordination number? Coordination number is the nearest, please remember, coordination number is the equal and nearest available number of atoms. तो आपको ये ढूंढना है कि दिए गए एटमिक स्ट्रक्चर में, क्रिस्टलोग्राफिकल स्ट्रक्चर में, नियरेस्ट सबसे नज़दीक वाला एटम एंड एट द इक्वी डिस्टेंस, माने 3-4 एटम है, उसमें से 2 एटम सिर्फ आइडेंटिकल नियरेस्ट है, लेकिन बाकी के 2 एटम है वो थोड़े बहुत वेरिएंट डिस्टेंस पे नज़दीक पड़े हैं. सो वी कांट कंसिडर that 2 atoms which are different than the other 2. So, in nutshell, you should have to underline those atoms which are very nearest. So, it's a superlative degree. Nearest, that means सबसे नज़दीक होने चाहिए. The second caption of the definition is it should be the equidistance, माने जो भी आप एटम गिनो वो सभी का डिस्टेंस इक्वल होना चाहिए, उसके साथ भी वो नियरेस्ट भी होने चाहिए. सच एटमिक नंबर्स आर रिफर्ड एज अ कोऑर्डिनेशन नंबर. तो सिंपल क्यूब में कोऑर्डिनेशन नंबर है 6. उसकी फिगर बुक में नहीं दी गई है, सो आई हैव चोजन अप फ्रॉम द ऑनलाइन एंड यू कैन सी आई हैव चोजन द सेंट्रल पोर्शन ऑफ इट. So, one on the front part, one on the back part, one on the left part, one on the right part, one atom on the top part and one atom at the bottom part. In addition to that, they are giving how you can consider the 6 atoms, and therefore in a simple cube you having a 6 coordination number. Okay. So, nearest neighbor distance is twice of r. The another figure will give you a better result of it. So, this is a simple cube, 4 atom at the top, 4 atom at the bottom. My visualization for this particular simple cube is such that the atom at the one corner and atom at the bottom corner and their surface are touching to each other. That means इसकी radius r, ऊपर वाले की radius भी r. So r मिला के twice of r, that would be equivalent of my size of cube, and that is nothing but your cubic lattice parameter, that is a. Since this is a cube, so a, b and c all are equal. Alpha, beta and gamma, that is the angle between the a, b and c respectively, that would be also 90 degree, and that geometry, that is what the mean of cube. So number of lattice point is 1. Volume of all atoms in a unit cell. कितने atom है मेरे पास? 1 atom. How shall I calculate that? Just look at the previous slide again back. And here you can know there is a 8 corners, and 8 corners contribution is 1/8. So total number of atoms will be 1, and therefore the 1 atom multiplied by 4 pi r cube, where r is the radius of atom. Do remember, r is the radius of atom. So volume of all atoms which are contributing to the unit cell, that would be given by small v, because atom is smaller. Now volume of the unit cell, because it's a larger one, so I have chosen the symbol is capital V, and since it's a cubic setup, so it's a, b and c are equal. This is, let us say, c, this is, let us say, b, this is, let us say, a, and a, b, c are equal, so it becomes the a cube. And since as from this figure I can speculate that a is equal to twice of r, so correlation between a and r is a is replaced by twice of r raised to cube, so it becomes the 8r cube. Am I right? And now we will be finding out the packing factor or the density of a packing. It is a synonym. Do remember, atomic packing factor, it's also known as a APF, or it is, some author are just writing not the atomic but just packing factor. So packing factor is ratio of atomic volume contribution to the unit cell volume contribution. I repeat again, packing factor or a density of a packing, that means it is a ratio of atomic contribution or the volume of a atomic contribution to the unit cell to the volume of a unit cell. ऊपर आएगा 1 into 4 pi by 3 pi r cube, so that is a 1 into 4 pi by 3 pi r cube, or divided by a cube, right? If you solve this equation, you are getting the pi by 6, because a will be replaced by twice of r raised to cube, so ultimately r get cancelled and some numerical figure will come, and that is comes out to be 0.52. If I convert into the percentage, then I should multiply by 100, and therefore it is appearing 52, and this says that the atomic packing factor of a simple cube is a 52%. उसका मतलब क्या? उसका मतलब ये हुआ कि ये जो सिंपल क्यूब है उसमें 52% जितनी जगह 52% जितनी जगह एटम ऑक्यूपाइड कर रहा है, और बाकी की जगह में खाली जगह है, which is shown by a white portion. Can you see this? So that is known as a, I think you had already remembered through the 11th and 12th grade standard, and that is known as a void. V-O-I-D, void. Void, that means the space within a crystallographical structure which is unoccupied by the atoms. I repeat, it is a space in a crystallographical structures which is not occupied by the atoms. तो अगर मैं पूछूं कि void का कितना परसेंटेज है, so you can say that its a void contribution is 48, क्योंकि 48 plus 52 कुल मिला के वॉल्यूम ऑफ योर यूनिट सेल, राइट. एंड अगर इसका रेशियो 1 आता है, कब आएगा कि जब भी 100%, माने ऊपर 4/3 पाई आर क्यूब इक्विवेलेंट टू ए क्यूब होगा, तो इसका रेशियो 1 आएगा. 1 से आप 100 से मल्टीप्लाई करो तो आंसर शुड बी 100. दैट वे यू कैन से दैट the rest part will be the void concentration or the void contribution. Okay, so now we will be focusing on a few highlight point. So some important crystal structure terms and defined below. Coordination number. The coordination number is defined as the number of equidistant nearest neighbor that an atom has in a given structure. Greater is the coordinate number, then close packed will be, that would be the more close packed. That means उतने number of atom ज़्यादा होंगे. If atom will be more, it would be more close packed. That means the density of packing will be higher. माने number of atomic contribution will be higher. We will see in the next part as well. So the full name is the atomic packing factor, that is APF. But in general, it is also tagged as a PF. Okay. So the fraction of the space occupied by the atom in a unit cell is known as the atomic packing factor. Or on basis of the equation also you can say that atomic packing fraction is a ratio of number of atomic contribution volume to the volume of a unit cell. अगर ये याद रहता है तो भी ठीक है, वरना ये more detailed information है. The fraction of a space occupied by the atoms in a unit cell is known as the atomic packing fraction, and the atomic fractions which is not occupied within a unit cell, which is known as a void. Okay, so try to remember that. The next one is the body centered cube. Body centered cube is given here. For another input, I had also given another internet figure, and that will be 4 on top of the face, 4 on bottom of the face, and 1 atom is in the center. It may necessary that this atoms is identical, it may not necessary that the same atom should be inside the cube. सो अगर यहाँ ध्यान से देखो तो इसको मैंने अलग टेक्सचर से बताया है और वहाँ पे भी अलग टेक्सचर दिखाया है. दैट मीन्स दिस एटम्स आर डिफर दैन द सेंट्रल एटम. इफ़ यू लुक एट टू द साइज वाइज दे आर ऑल्सो डिफरेंट. एनीवे, but right now for ease of us we are saying that the radius of each atom are identical. The 1/8 corner contribution, you can look at the 1/8 part of the atoms on each corner, and the central atom is the whole atom. So naturally the there is a separation between the atoms. अगर ये एटम की रेडियस बड़ी है तो ये अंदर का एटम इतना लार्ज होगा कि दो कोने वाले एटम आर नॉट जॉइनिंग टू ईच अदर बट दे आर सेपरेटेड बाय अ सर्टन डिस्टेंस ऑल्सो. माने यहाँ जो दो ए इज इक्वल टू ट्वाइस ऑफ आर आपने लिया था लास्ट एग्जाम्पल में, वो यहाँ जरूरी नहीं है. Okay, it's depend. Rather, I am not saying that it is always like that. It may possible it is like that. It may possible it may not like that. What it mean by that? If the radius of the inner sphere, inner atom is much larger, then your separation between two atoms are not touching their edges each other. You can look at here. ये कोने वाला एटम ये कोने से सेपरेटेड है, ये कोने वाला एटम ये कोने वाले एटम से सेपरेटेड है. सो इट्स डू डिपेंड ऑन योर साइज ऑफ दिस वन. Anyway, let us go with the calculation of the atomic packing fraction for a body centered cube. So calculation of the lattice constant. So here you remember that from this corner to this corner it's a body diagonal. I hope you can visualize through this particular line diagram of a body centered cube. तो सेंटर में जो पूरा आइटम पड़ा है that is with the twice of r. ये कोने वाला जो आइटम है वो सिर्फ 1/8 पोर्शन है, बट दिस डिस्टेंस विल बी इक्विवेलेंट ऑफ r. सिमिलरली दिस कॉर्नर C एटम इज ऑल्सो विद द रेडियस r. सो ये एक r हुआ. यहाँ पे डायमीटर पूरा स्फीयर है, पूरा आइटम है, सो इट्स अ ट्वाइस ऑफ r माने 1r प्लस 2r माने 3r, और ये एक और r. So r plus 2r plus r, so that would be the 4r. So diagonal length, that is C to F, is equal to 4r. Okay, अगर मुझे पाइथागोरस लॉ यूज़ करना है तो नीचे C to A माने फेस डायगोनल जो आपका A B C और अगर ये कॉर्नर से जो नीचे पैरेललोग्राम बन रहा है उसका वो फेस का अगर डायगोनल लूँ तो वो डायगोनल के लिए that would be another edge of a triangle and this is A of the third triangle. So अगर आप पाइथागोरस लॉ यूज़ करना चाहते हो तो आपका ट्राइंगल बन रहा है F A C F. Can you see this triangle? C F और A, right? तो C to A that is a face diagonal. So यहाँ पे AC के लिए आपको ढूंढना पाइथागोरस लॉ यूज़ किया. सो इट्स ए स्क्वेयर क्योंकि दिस इज़ ए, इट्स अ क्यूब, सो दिस इज़ ऑल्सो ए, सो इट्स अ ट्वाइस ए स्क्वेयर. और उसका अगर रूट ले लो तो हो जाएगा अंडर रूट ऑफ 2a. ओके, अंडर रूट 2a that was the length of AC. Anyway, now my main aim is to find it out the FC, that is the FC line segment of the triangle, which is equivalent to 4r. According to Pythagoras law, it would be AC square plus AF square. AF square, that is A square, AC square is equal to twice A square, and FC square is equal to 4r square. So ultimately I am able to get A is equal to 4r under root 3, or I can say that twice of r is equal to A root 3 by 2. I say repeat, अगर यहाँ का 2 मैं यहाँ के 2 डाइवर्ट कर देता हूँ और ये 3 ऊपर जाएगा, ये 2 नीचे आएगा, so it become twice of r is equal to A root 3 by 2. So with this logic we can go with the next step of calculation. So nearest coordination number over here, that is the 8. Let us have a visit again and check it up what exactly it is. So कोऑर्डिनेशन नंबर इज़ 8. अगर ये बॉडी सेंटर वाला सेंट्रल स्फीयर वाला जो सेंटर्ड एटम है उसको मैं अगर फोकस करूँ तो 4 ऊपर हुए और 4 एटम नीचे हुए. सो दिस ऑल 4 एटम्स and this all 4 atoms are the nearest and the equidistant atoms. So total coordination number in body center, that would be 8. So the very first line I am writing here 8 coordination number. Second, the point that is nearest neighbor distance is twice of r. ओके, माने मैं यहाँ पे ये सोच रहा हूँ कि जो एज पे 2 एटम है वो एक दूसरे को छू रहे हैं, दे आर टचिंग देयर सरफेस टू ईच अदर, दैट मीन्स ए इज इक्वल टू ट्वाइस ऑफ sorry. So as we had calculated, A is equal to 4r by 3. So the relation between the r and the A is that is A is equal to 4r by root 3. अगर मैं twice of r पकड़ लूँ तो twice of r is equal to A root 3 by 2. So they are saying that the nearest neighbor distance, if I consider it as a twice of r, it would be the equivalent in terms of lattice constant, that would be the A into root 3 by 2 times. So now lattice constant A is equal to 4r by root 3, that what we have calculated. The number of atoms per unit cell, अगर ध्यान से देखो तो एक एटम तो पूरा यूनिट सेल के अंदर ही बैठा है, that is the center portion, so that is a 1, and 4 and 4 8 atoms are at their corner, so that would be 1, and corner atoms are contributing 1 8, so 1 8 into 8, that is 1, and plus 1 additional atom that is in center, so that is this one. So total available number in a body center or BCC, that is the available number of atom, is 2. So volume of the atoms in a unit cell, that is always referred by a small v, so 2 multiplied by 4 by 3 pi r cube, and the volume of a unit cell, again still it's a body centered or a cubic setup, so it's a cube because lattice parameters a, b and c are equal, so it becomes the L, B and H, or L into B into H, and all are equal to A, so it becomes A cube, and therefore it would be A cube का रिलेशन आपके पास है. अगर यहाँ पे क्यूब कर रहे हो तो यहाँ पे भी क्यूब करना पड़ेगा, सो 4 रेज टू क्यूब, r रेज टू क्यूब, और रूट 3 रेज टू क्यूब, सो इट बिकम अ 3 इंटू रूट 3, 4 का क्यूब हो गया 64 और r का क्यूब हो गया r3. And then the last set of equation APF, that means atomic packing factor, or in briefly you can say the packing factor, that is small v upon capital V. Small v is the volume contributed by the atom per unit cell, and V is the contribution of the volume of a unit cell, and therefore the scenario is this: RR get cancelled and the certain number will come. The number is coming 0.68. अगर परसेंटेज निकालना है तो 100 से मल्टीप्लाई करो, सो दैट वुड बी द 68%. सो BCC स्ट्रक्चर इज क्लोजली प्लेक्ड स्ट्रक्चर कंपेयर टू सिंपल क्यूब, क्योंकि सिंपल क्यूब का मुझे एटॉमिक पैकिंग फैक्टर मिला था 52. अगर 52 से यहाँ पे मैं देखूँ तो एटॉमिक कंट्रीब्यूशन ज़्यादा होगा. कैसे कि उसमें एक था, यहाँ पे 2 एटम है, तो एटम्स आर मोर क्लोज टू ईच अदर. सो BCC इज़ मोर क्लोज पैक स्ट्रक्चर कंपेयर टू सिंपल क्यूब. ये एक समझने वाली बात है और समझ में आ भी रहा है, और न्यूमेरिकल फिगर से भी पता चल रहा है कि 52 से 68% ज़्यादा है. सो नेचुरली एटॉमिक फैक्टर्स इज मोर. दैट सजेस्ट दैट available number of atoms contributions in this unit cell is more compared to simple cube. Closest packing, what it mean, and that is in the cubic, that is FCC. So face centered cubic close pack. And to see this one, let us have the next discussion. Now in the FCC, if you remember the diagram, then it would be easy, but always draw the diagram so it would be very clear to understand it. This is FCC setup. One is at a face and 4 are at a corner. So such all the 6 faces will be like this. If you look at the top face, if you look at the right face and so on. So अगर मैं यहाँ फेस का ही डायगोनल ले लूँ, क्योंकि इसमें सेंटर में कोई एटम नहीं है. ओके, now how I shall understand this one? How many faces are I do have? I do have a 6 faces and each face carries 1 atom. तो अगर ये फेस का एटम है, that is a contributing to this particular unit cell is 50%, क्योंकि 50% will be in the neighboring wall and 50% to its own wall. Okay, whereas corner contribution to this unit cell is 1/8. Okay, माने 3/8 part are for the other, 5/8 part are for the outside the unit cell, 3/8 part are within the unit cell. यहाँ पे 50% माने 1/2 part inside the unit cell, 1/2 part outside the unit cell. अगर यहाँ का कैलकुलेशन अगर ध्यान से देखें तो coordination number is 12. So coordination number is in this particular, I forget to put a picture over here, but if it is possible I will try to get it and I will show you how exactly the figure could be possible. I had already saved for you, but somehow I forget to let me have the coordination number, and coordination number is here. So this is your, you can look at how exactly I would like to visualize the coordination. So this is FCC. Can you see the each face having a 1 atom? This is back side, this is front side, this is bottom side, then this is right hand side. So यहाँ पे एक और दूसरा FCC होगा, right? और यहाँ के कोऑर्डिनेशन, सो अगर मैं ये एटम को, द जॉइनिंग वॉल वाला एटम को अगर मैं कोऑर्डिनेट करूँ तो 1 2 3 4 इन अ मिडल प्लेन, 1 2 3 4 ऑन अ टॉप प्लेन, 1 2 3 और 4 ऑन द बॉटम प्लेन. सो टोटल 4 4 and 4. So total is a 12 coordination number are visualizing here, and that is what you can see, the 12 coordination number is here. Now the lattice constant A that we have to calculate it, that is again come 4r by root 2, and the nearest neighbor distance is twice of r. This we will just see. Now the total number of atoms वो calculate कर लेते हैं कैसे. So yeah, that is here. There are 8 corner atoms, 1 2 3 and 4 on top, 1 2, 3 and 4 are on bottom. So 8 atoms, contribution to each atom to this particular unit cell is 1/8. So that would be 1 atom. Now 6 faces, each face carries 1 atom. 1, 2, 3 and 4, पीछे वाला 5th, आगे वाला 6 atom, and since it's in the wall, so the contribution is 1/2. So 6 into 1/2, so that is 3 plus 1, so it is a 4. So in this particular FCC setup we do have a 4 atoms contribution. अगर फिर से कंपेरिजन करें तो सिंपल क्यूब में 1 एटम था, बॉडी सेंटर में 2 एटम थे, और एफसीसी में और ज़्यादा हो गए, माने 4 हो गए. सो लॉजिक ये बता रहा है कि एटॉमिक पैकिंग फैक्टर या तो पैकिंग डेंसिटी इसमें सबसे ज़्यादा होनी चाहिए, एंड देयरफॉर इट इज सेइंग इट इज़ द मोस्ट dense cubic setup or cubic close pack. Okay, and let's go to the next calculation, how exactly we are able to develop this particular relation. So कैसे हमने फाइंड आउट किया, मैंने आपको बताया था पहले कि ये बॉडी डायगोनल आपको ढूंढना है. सो दैट इज़ हाउ मच इट इज़, सो r प्लस ट्वाइस ऑफ r प्लस r. तो this face diagonal become 4. Naturally this is also a and this is also a, so it's a and a. So one of the face cross segment is shown over here. From this you are able to find it out to develop the value of relation between a and r is coming, a is equal to 4r by root 2. Okay, it's a simple Pythagoras law, so there is nothing difficult mathematics, you can do it very well. And therefore if there is a 4 atoms are there and 1 atom contribution is 4 pi by 3 pi r cube, then multiply by 4. So this is total volume of atoms pertain to this particular FCC setup. It's a still cubic setup, so the unit cell or the volume of a unit cell, that is a edge length is a, so that volume of that would be the a cube, and therefore it's a 64 r cube 2 root 2. So atomic packing fraction is the ratio of atomic volume contribution to the unit cell divided by or to the volume of a unit cell, and therefore it is like we are getting the relation root 2 pi by 6, and it's coming some around, not some around, exactly 0.74. And this 0.74, if I need a percentage, I should multiply by 100, तो ये हो गया 74. इसका मतलब ये हुआ कि 74% इज़ द पैकिंग डेंसिटी. माने सिंपल क्यूब में आ रहा था 52%, बॉडी सेंटर में आ रहा था 68%, और फेस सेंटर में हो गया 74%. सो नेचुरली अगर आप तीनों का कंपैरिजन करें तो अगर मेरे पास कोई एक क्रिस्टलोग्राफिकल स्ट्रक्चर है वो सिंपल क्यूब का बना है, और दूसरा से मेरे पास एफसीसी माने फेस सेंटर क्यूबिक सेटअप है, अगर दोनों का में सेम साइज़ है, दोनों का एटॉमिक रेडियस इज़ ऑलमोस्ट सिमिलर है, तो अगर ऐसे क्रिस्टलोग्राफिकल स्ट्रक्चर का अगर मैं बॉइलिंग पॉइंट या तो मेल्टिंग पॉइंट या तो बॉन्ड लेंथ जो भी अगर आप चेक करो तो सभी एफसीसी में ज़्यादा होंगे लॉजिकली, क्योंकि दे आर वेरी क्लोज टू ईच अदर. So naturally nuclear attractive force will be much stronger compared to the simple cube, and so on. And as well as there is more number of atoms, so you require more energy to segregate those number of atoms. So boiling point will be high, melting point will be high, bond strength will be high, and so on. So in nutshell, by knowing the more information about the packing density and packing fractions about the crystallographical structures, you can dig it out few important information for a given crystallographical setup. This is very much useful tool, especially when you are designing something new molecules. सॉलिड स्टेट केमिस्ट्री करके एक पूरी ब्रांच है. तो जैसे कि अभी कोरोना चल रहा है, तो आपको पता है कि कोरोना की वैक्सीन मुझे ढूंढना है, नॉट मुझे, आई मीन in a research and development, unit cells are finding out the vaccines for that. Now अगर वैक्सीन ढूंढना है तो नेचुरली यू शुड हैव द स्ट्रक्चर ऑफ अ वायरस. अगर वायरस का स्ट्रक्चर आपको पता चले तो आपको ऐसी एंटीबॉडीज़ डेवलप करनी है विच इज़ फिट विद दिस पर्टिकुलर वायरस स्ट्रक्चर। तो आपको यहाँ से थोड़ा बहुत आइडिया मिलेगा कि स्ट्रक्चर जानने से आप मोलिक्यूल की रूट तक पहुँच सकते हो। तो अगर कोरोना वाला वायरस का स्ट्रक्चर और ये आपका डिज़ाइंड मोलिक्यूल का स्ट्रक्चर अगर सेट हो गया, देन एंटीबॉडी विल बी able to merge out with this particular virus one, and your drug will be effectively implemented on such kind of the virus. फिर ड्रग की स्ट्रेंथ, फिर ड्रग मोलिक्यूल की रिएक्टिविटी विद द वायरस, एंड दिस ऑल आर द डिफरेंट एंड many complex biochemistry will be there. But I am just looking with the angle of a physics, with the angle of a solid state chemistry, ki how I can this my knowledge will be useful to this particular current hot cake existing topic. Anyway, so it's just an example to correlate your present topic to the existing pandemic situation. Okay, so the next part is the hexagonal close pack setup, and hexagonal close pack is again 74. So the strength wise, and that is will be again similar to the FCC. हेक्सागोनल में दो तरह से विजुलाइज करना ज़रूरी है। मैंने फिगर डालना भूल गया हूँ, लेकिन दिस इज़ द बुक फिगर। अगर ध्यान से देखो, जस्ट पॉइंटेड ऑन दिस पर्टिकुलर हैंड मूवमेंट, तो ये एक बेंजीन रिंग ऊपर हो गई, एक बेंजीन रिंग नीचे हो गई। ईच बेंजीन रिंग कॉर्नर हैविंग वन एटम, सो 6 आर एट द पेरिफेरियम and 1 at the center. So total is the 7 atom at the top, 7 atoms at the bottom, correct? 7 plus 7 14, and 3 atom within a unit cell, right? So अगर यहाँ ध्यान से देखो तो ये हेक्सागोन रिंग का जो क्लोज पैक सेटअप है, सो हेक्सागोनल क्लोज पैक स्ट्रक्चर है, उसमें अगर आप ध्यान से देखो तो 3 ऑर्थोरोम्बिक सेटअप है। यहाँ पे देखो, दिस इज़ योर वन डॉटेड लाइन इज़ ए, दिस इज़ योर बी, सो एक्स एक्सिस, वाई एक्सिस, and this is central one is the z axis. ओके, सो लेटिस पैरामीटर की बात करो तो ये हो गया a, ये हो गया b, और ये हो गया c. ओके, नाउ looking to this setup, your a and b is equal, your a and b is equal, but c is not equal. Secondly, c और a के बीच में 90 डिग्री है, C और B के बीच में भी 90 डिग्री है, लेकिन A और B के बीच में 120 डिग्री है। ओके, सो क्योंकि दिस कैरीज 2 ट्राइंगल, राइट? सो 1 2 3 4 5 and 6 triangles within Benson ring. So you can just, this is a equilateral triangle because this is also a, this is also a, and this is also a. So equilateral triangle, that means a 60 angle into this. So 60 plus 60, that is become 120. So 120 here, 120 here, and 120 here, so it become circle, and that is the atomic circle over here. You can visualize that. So it's a 12 3 is 360. So that is another way of logic to understand how it becomes the 120. Otherwise, you are knowing that in hexagonal pack, that is A is equal to B and not equal to C, that is the lattice parameter, and the second one is alpha and beta is equal to 90 and gamma is equal to 120 degree. Anyway, so this closed plate structure is little bit complicated. You have to focus your eyesight on this PowerPoint presentation, then it will be easy for you. So अगर यहाँ का मैं एटॉमिक कंट्रीब्यूशन देखूँ या तो कोऑर्डिनेशन नंबर देखूँ, तो दैट डिटेल वी विल बी फॉलोइंग अप नाउ, एंड द टोटल नंबर ऑफ एटम, लेट अस कैलकुलेट दैट. सो अगर ध्यान से देखो तो कितने आ रहे हैं, 6, 3 तो यहाँ है ही, सो विद इज विद इन सेल, तो 3 एज अ होल नंबर. अब क्वेश्चन होता है 3/2 3/2 कहाँ से आए, ठीक है? तो 1 2 3 4 5 6, और नीचे वाले 1 2 3 4 5 और 6, ये 6 एटम्स माने 6 और 6 12 एटम्स, और 12 एटम के कंट्रीब्यूशन हो गया 3/2 and the contribution of the central 2 atoms on the face, I think it should be 1/2, so it's a 1, it's a 4, 3/2. Okay, let us say the coordination number over here is a 12, so you try to correlate that how it is a 12 coordination number. So you can say having a 1 2 3 4 5 and 6 are here, and on the another or I think from this particular point you can think of, so 1 2 3 4 5 6 7 8 9 10 6 will be here, then this is okay. So अगर मैं यहाँ से गिनूँ तो 12 कैसे होंगे ये मैं आपको बता देता हूँ. This is the peripheral one is at the same distance. फिर ये जो distance है the central 3 and the up ऐसे ही ऊपर वाले 3 होंगे. So that 3 and the bottom 3 are identical, so that would be the 3 plus 3 6 and the peripheral are the 6, so that is become the 12 coordination number. Okay, the closest distance mane we are also assuming that the atom at this corner and atom at this corner and that edge are touching to each other, and therefore A is equal to twice of R. Remember that this all 6 triangles are equilateral triangles, so it's A and A. So I am saying that this is a twice of R is equal to A. The top layer contains 7 atoms. Each atom is shared by 6 surrounding hexagonal cells, and the central atoms is shared by 2 surrounding cells and 3 atoms within the body cells. So with this logic I can have the total number of atoms will be 3/2 plus 3/2 plus 3, that is equal to 6. Okay, and now I need to calculate the relation for the C by A. The interesting ratio is the C by A. Once you know the C by A, then you are able to find it out the packing density or the packing fraction of this one. Okay, so the cos 30, so this is a triangle of over here, and if I know that's a AY, so this is A, this is Y, this is A, this is O is in your center, so this is AOB, so the same triangle is here AOB. Okay, and now from AO, and I am taking a one normal to on the OB. Okay, so one normal, that is AY on the OB, and this OB AY is on the OB line segment, correct, and therefore we are splitting the angle A, and half of the angle, that would be 30. So if I wish to know the length of AY, I would go with the cos 30, and cos component, that is the AB cos component, so this is your hypotenuse, so AB cos component or AB cos theta or AB cos 30, that is equivalent to AY, and therefore AY is equal to A cos 30, and that is A root 3/2. Another way of logic is just apply the Pythagoras law. This is also A, and this would be is equal to A by 2, so it will comes around A root 3/2. That is a one way of logic. Okay, now this 3 of atoms are lying at the diagonal angle of, because we have just calculated it's a 12 coordination number, and this distance is also A, so that I am saying this is top Z atom, which is one of these 3 atom inside, and that would be lying at the A. So this axis is the C axis, the parallel to the Z coordinates. Okay, and that would the height of z to x, that is equivalent to c by 2, that is equivalent to c by 2. So, but that is a pure Pythagoras law could be applicable. So, a x square is equal plus zx square is equal to a square. So, that is what I wrote here, a z square plus ax square plus zx square, and we substitutes their values, we are getting the ax is equal to a root by 3. So, we have find it out the value of x first of all. Okay, once you know this value of ax, or you can understand like this particular ax that would be the 2/3 of the ay, that is of a 2/3 of a ay, because when you join this all the three vertex, and that, so the joining point that would be the 2/3 of your normal. So, 2/3 of your ay, and 2/3 of your ay that will give me, this is your ay, उसका 2/3 ले लो तो आपका हो गया a by root 3. So, ax is equal to a by root 3. Now, once you know the ax, you also know the az, so you are able to find it out the zx. So, for the value of zx, you are able to get it, the value zx, that is ax square आपको मिल गया. So, zx square आपको, zx square is equal to c by 2. So, it's a c square by 4. आपके पास ax भी है, ax is equal to a by root 3. So, square of that, so a square by 3, and ax, that is a, so that is a square. So, इसके ऊपर से आपको c by a का रेशियो 8 by 3 raised to 1/2 मिल गया. So, that is a c by a ratio. What is the need of c by a ratio? The picture will be more clear in the next one. So, the area of the hexagonal one. So, there are 6 areas, 6 triangles are, so 6 times the area of the AOB. So, that would be the area of the base, and that would be multiplied by the height, so that is C. Okay, so the area of a triangle, that is 1/2 base into normal. So, that is comes out to be this much, 1/2 a into a root 3 by 2. So, it is a 1/2 a square root 3 by 2, or otherwise you can say the a square root 3 by 4. So, the area of the base, that is 6 multiplied by the above parameters. So, that would be the total area of my base, and this base area, that is 3 by 2 root 3 a square, 3 by 2 root 3 a square multiplied by c, that is the height of your hexagonal benzene ring, or one benzene ring to the another benzene ring. So, that would be c. So, that would be the height of my total benzene ring, volume of the unit cell. So, volume of the cell, that would be this one. Now, coordination number is 12, lattice constant is a is equal to 12. So, nearest neighbor will be twice of r is equal to this. The number of the atoms per unit cell is the 6, as we had calculated. 6 are at the corner. So, 6 plus 6, so that is a 12. 12 atoms, and their contribution is a 1/6. So, 1/6 into 12, so that is giving you a 1 atom. Then the face atom is also face atom is also 1/2. So, 1/2 plus 1/2, so it's a 2. 2 plus 3, so is ultimately it become the 6 atoms are contributing. So, the number of the atoms per unit cell, that would be the 6, and therefore 6 atoms multiplied by 4 pi by 3 pi r cube, and that will be the volume of the atomic volume to the unit cell, that is this. Volume of the hexagonal unit cell, that is a 3 by 2 root 3 a square c square. C का ratio आपको पता है, c by a, so that you also substitute over here, and therefore finally atomic packing fraction you can having the 0.74, or percentage wise 74%. There are few examples are given there, and that is how I am able to touch this all the atomic packing fractions. So, this is one of the topic you have to be part of your CIA 2, and one more lecture I am just uploading today, and that would be the Miller indices. Thank you so much for paying attention. Stay home, stay safe. Thank you.